All right, here we go. So here we've got some angles. We have A, B, D. Okay, now this is interesting. This is a little bit different than our first example. So I'm going to highlight. Here's A. This is angle ABD. Okay, and I know that because B is the vertex, and then the other letters I'm finding those points. And it's telling me here that that angle measures 60 degrees. All right, and then it gives me another angle. It gives me angle ABC, which is this one here. And it's telling me that that angle measurement is 28 degrees. Okay, so let me see if I can zoom in a little bit here. All right, so this one, that green is 28 degrees. And then the entire yellow angle is 60 degrees. So from, yellow to yellow, 60 degrees. So what it wants me to find out is, well, what's angle CBD, which would be like this red part right here. So how do I figure that out? Well, I know the big angle. I know the yellow one is 60. I know the small green one is 28. How could I figure out the red angle? What I'm going to do is I'm going to take, in this case, I'm going to take the big angle, 60. I'm going to subtract away the small angle that I know, which is 28 degrees, and that should give me what's left. So that should give me what's in red. Okay? So 60 minus 28, well, let's see, I know 60 minus 20 is 40, and 40 minus 8 is 32. So the red angle should be 32 degrees. And then, can you think of a way that you could check that work? So right now I just said that this red angle is 32 degrees. What's a way that I could go back and double check to see if I'm right? So hopefully you can tell that like the green angle and the red angle are adjacent. They're right next to each other. If I add those together, that should give me the full yellow angle, right? So I'm going to double check my work. Is 28 plus 32? That should give me 60, right? Well, 8 plus 2 is 10. 3, 4, 5, 6. Yep, sure enough. 28 plus 32 is 60 degrees, which is the large angle. So I know I'm correct. So using two angles to figure out a missing angle is kind of what we're going to be doing today. Let's take a peek at the second one. All right, here we go. We've got some different points now. We have E, F, G, H. All right, so I want to look over at the right at the information that I know. So I know that angle EFG is 33 degrees. Okay. There's that one. I also know that GFH is 90 degrees. So GFH, that makes sense, right? That looks like a 90-degree angle. That's 90. And I want to figure out what is angle EFH, which would be this large one. So what could I do to figure out the angle of the large red angle? I know that the yellow is 33. I know that the green angle is 90. How do I figure out the large EFH angle? Yeah, I should just be able to add the two adjacent angles, right? So 33 plus 90 123. So angle EFH should be 123 degrees. Okay. You could double check that in a couple of different ways. You could take 123, subtract 90, see if you get 33. You could take 123, subtract 33 and see if you get 90. Lots of different ways to double check that work. All right, so this is sort of what you'll be doing in your assignment today. Your assignment is in Class Kick, and it's called Finding the Missing Angle. The worksheet looks a little bit different than this one. You're going to be solving for what they call like angle A in each of the different problems, but it's exactly the same thing. So either finding the large angle or finding one of the smaller adjacent angles. Please email if you have any questions. Good luck, and may the force be with you. Hey, Mob family, it's Miss Moldenhauer, and we are ready for Friday's math lesson, where we're going to be talking about adjacent angles. That word adjacent is a great math word, and you can kind of think about it as when somebody is like right next to someone else. So like think about, if you're sitting at your kitchen table with your family and someone's sitting in the spot next to you, you could say that you're kind of like adjacent to one another. Or like thinking about your house and then your neighbor's house are sort of like adjacent to one another. They're sitting right next to each other. And so we're going to be using that word to talk about angles. So adjacent angles are two angles that share a common ray. So basically they're right next to each other. So in this picture that I've drawn, and I apologize that I didn't use straight lines. I couldn't find them and explain everything. So anyhow, you guys can see that I have one angle here and then a second angle right here. Also, I believe that Mr. O'Brien talked to you guys a little bit about naming angles. So I have two, here are my two angles. So the first one is this. And what you can do is you can make a little angle symbol. So that's the symbol for angle in math. And I can call this angle two different things. I can either call that first one that I highlighted in blue ABC, or I can call it CBA. The only thing about, and you use the points there, so I've labeled them with a letter. The only thing you have to remember when naming angles is that the vertex letter, so in this case the vertex is point B, it has to come in the middle. So if I wanted to name that blue angle, I would probably just call it ABC. But CBA works as well. It doesn't matter the first and last letter. It just matters that your vertex is in the middle. Okay, so that's angle ABC. And then the next one, which I could highlight, so here's the other angle, right? So I could call that yellow angle. Can you figure it out? You could either do CBD or you could do DBC. It doesn't matter. So I'm just going to call it CBD. So as long as that vertex letter comes right in the middle, as you can see in both of these, the B is the center, or is the middle letter there. So that's naming angles. So what I could say is that angle ABC is adjacent to angle CBD. And what we're going to be doing today is using adjacent angles to help us to find missing angle measurements. So I'm going to show you that on another page.